Hi friends, welcome back to another session on operating systems concepts. Now let's see the overview of the various functions provided by the operating system. First, let's begin with what we call process management. The process management has various functions like creating a process and terminating a process, scheduling the process when we have more than one process which is being active, but there is only one processor, then any given time only one process will be working, all others have to remain inactive, and this is taken care by the scheduling of the process under the process management. So when the process is interacting with the IO devices and other peripherals, then there has to be proper synchronization, so that's taken care by the process management. The communication among the processes is another activity taken care by the process management. There are various resources available, and these resources have to be properly shared among the processes, and this responsibility is also with the process management system. Then each process will be in different states depending on what currently it is doing. It may be a state where it is waiting for the CPU for its turn, and that's a waiting state. And once the CPU is made available for this process, then we say it is a running state. And while running, if it wants to interact with any slower devices like IO devices and all that, it can't wait there, so it just come out of that and starts again waiting for the response from the IO device. But there are two types of waiting. One is waiting for its turn to get the CPU, that is the scheduling, and another one is waiting for the response from the IO device, which is very, very slow. So all these things are taken care in the process states, and every process is given with the details, and these details are stored under the process control block. So what's process management? It's essentially used for efficient resource utilization. It maintains the stability of the system, making sure that the resources are properly allocated to the various processes so that everything runs smoothly. So there is no instability in the system. Very much useful when we are working on multitasking and multi-programming environment, and makes the user experience more smooth, and gives a simple uh, work for the users to do. Most of the work is carried out by the process management component of the operating system. So looking at the process management, so first we just like to define what a process is. A process in turn is a program in execution. So as long as the code is there in the secondary memory, then it is called a program. But once we start running it, or when we wanted to execute that, the first step happens is this program is loaded onto the main memory. So when it is loaded onto the main memory, then it becomes a process, and along with the code, it will also have its own state, whether it is in waiting state or it is in the running state and all that. And along with that, the data of various variables and all that also is stored along with that on the main memory. All these three together will form a process. And this details about a process are stored in the process control block, where the various components are there at any given time. What is the process state, what is the process number, and what are the components of the registers, memory limit, and what are the files that are opened by this particular process, and exactly where this process is situated. So pointer to the process and all that are available in this. More details we get into when we see the process management part in detail in the coming sessions. So just an overview we are giving here. So various states are there. So when a new process is formed, that means when we won't like to run any new program, then the first thing happens is that program comes onto the main memory from the secondary memory. So whenever a main memory is written by the code, then that code is now onwards called a process, and that's a new process. And once a new process is made available, then it gets into the ready state, that it is ready to be run. And whenever the CPU is free, this particular process is allocated to the CPU, and CPU starts running it. And while running it, it may end up with three situations. One is many processes are waiting for their turn. So we may allocate a fixed time for each process. Then once that time is over, then it is interrupted, the processor is interrupted, and because of the interruption, the current process gets into the ready state back, and another process which is ready will start running. The other option is that it wants to get some input from the external device like IO devices, maybe keyboard or the secondary drive and all that, which are very, very slow compared to the processor speed. Therefore, it's not advised to wait indefinitely for the slow inputs available. So we can just stop the process and keep the process under waiting state, and let it keep waiting for that particular event to happen, maybe that reading event or writing event. Once the event is completed, then the process gets back onto the ready state. The third possibility of getting out of the running state is it has completed its execution, then it exits, and then it gets terminated. So this is the overall situation we have. So when we are working with multiple processes, what exactly we are trying to do is multiple process, maybe one word processor is open, one email system is open, one web browser is working, one antivirus is working, and many such things. We are keeping them open simultaneously, and all of them may be working and under logical level if you look at it. So one side, one of the browsers may be downloading some file from the internet. On the other side, we are typing something on the email. On the other side, we are trying to upload some document on the email and sending to someone else, and the back end, the antivirus is working and all that. But whatever it is, but when it is being executed, it has to be done by the CPU or the processor. And in our earlier system where there was only a single processor, then under normal case only one of them should be working. But to make sure that everything is running simultaneously, or to logically show that everything is working simultaneously, just because we know that the human response time is quite slow, very, very, very slow compared to the processor speed. Therefore, on one side you can make the email, we can keep typing on the email. On the other side, one more email maybe downloading something. On the third side, one more email maybe we are uploading some document onto the email and all that. All these operations for us, a user, it appears to be done concurrently, but in reality, they are not done concurrently, because to do these actions, the processor is required, and we do have only one processor, and this one processor has to be used for all this. So some sort of scheduling is done by the operating system. So it allocates one process at a time to the CPU, and then CPU works for that. And if these are done at a high speed, then we logically think that all of them are running parallelly, but in reality, only one will be running at any given time. So that's what a major contribution of process management is. It's what we call scheduling. So we can just look at the same situation in another way. So we have a ready queue. So all the processors which are ready to be executed will be available in the ready queue, and the one which has come earlier on the queue is allotted the CPU, and if it has completed its job, it just moves out, or it may stop execution for reasons like the process has asked for some IO request, and IO is very slow because there is human interaction required, like keyboard reading or mouse reading, or maybe even we are getting the data from the secondary drive like hard disk and all that, which have mechanical movements and all, which are very slow compared to the speed with which the processor is working, the motherboard is working, and all that. And so instead of keeping our CPU waiting for all this thing to happen, we can just say that let me stop working with you. You take care about your IO, and then once you are ready, tell me. So it just stops the execution whenever it gets an IO request. And when we get an IO request, it puts the IO request onto the IO queue, and then whenever that IO system is available, it is executed, and then once it is done, it comes back to the ready queue. The other thing maybe for each process a time slot is allocated. So if that time slot has completed, then on the expiry of this time slot, the CPU stops executing that particular process and takes up another one. So once the allotted time is over, then it's put back onto the ready queue, and it keeps waiting for its turn. Otherwise, the process may create another child process, and will wait till the child executes its work. And once child executes its work, it will come back to the thing, or it may be interrupted for some other issues. So wait for the interrupt. So we have asked for IO device to get something, and IO device is getting it. So once we allot the work to the IO device, it starts working, and then when it puts the data onto some buffer, and once the data is put on the buffer, then the IO device will interrupt our processor, and this interrupt completes this task, and then get back to the ready queue. So this whole thing is something to do with the scheduling. Scheduling, we have two types of scheduling. So scheduling means assigning the CPU to the processes. So we have two types of scheduling. One is called preemptive, another is called non-preemptive. Preemptive means the processor has a right to stop any process in between and get serving some other process. So that's a preemptive scheduling. Non-preemptive scheduling means once a particular task is started executing, till the execution is completed, other tasks cannot be taken up. That is non-preemptive. Under preemptive, we have different types like priority scheduling, shortest remaining, or longest remaining, or round robin. On the non-preemptive, we have first come first serve, shortest job first, longest job first, or highest response ratio next, like different types of scheduling algorithms. So let's look at what the preemptive scheduling is. In the preemptive scheduling, the operating system can interrupt a running process and switch to another one. Yes, that's what we meant by preemptive scheduling. That is, now operating system can say, "Stop, your turn is over. Now let's give chance to some other process." Here, it's not necessary that the process should have completed its work. So even if it is not completed, it can stop. The stopping may be for various reasons, like the allotted time is over, so something like round robin, like scheduling, or maybe some more important task has come up. So it is less important task have to stop and wait till the more important task is to be done. So that's a priority scheduling and all that. Then we have another type of scheduling which is called non-preemptive. It's the running process cannot be interrupted by the operating system. So once the process starts running, then operating system has to wait till that process completes its job. Both have their own advantages and disadvantages. We'll see what each one is going to talk about. So under the basic, the preemptive scheduling allocated process for a limited time, whereas non-preemptive scheduling, there is nothing like allocated time. So it is made available. The process continues to run till the process completes, or maybe because of external IO requirement and all, it may get into waiting state, but it will not go into ready state again. So once it will be in the ready state, ready queue, then once it is switched to the running state, then it will not go back to the ready state. It can go back to ready state only through the waiting state. So as far as the interrupt is concerned, the process can be interrupted in between in the preemptive scheduling, but in non-preemptive scheduling, nothing can stop it. Overhead, it has got overhead of scheduling process, and in this non-preemptive, there is no scheduling overhead. Whereas preemptive scheduling is flexible and non-preemptive is rigid. So if you are given the sequence in which a process has to run, then it will always follow that particular sequence until the work is done. It will not stop. So some of the advantages, disadvantages of each one, you can see that. Now getting into the preemptive scheduling, one example will be the round robin. So many processes are there, only single process is there. So in the first, we can give a process one, maybe 3 units of time. After 3 units of time, it gets into a process one, maybe of 3 units time, but each one is given 2 units of time. So after 2 units, process two gets in, then after 2 units, process three, then process four, then process five, then process six, then process seven, and then process eight. In the process one, it wanted 3 units, but we had provided only 2 units in the previous cycle. So now one more unit is required. So 1 unit of time is again given to process one, then 2 units of time remaining is given to process two. Process three wanted 2 units, so it was given 2 units, so no more process three is existing. 1 unit of process four is still pending, so this way it keeps on doing. Then we can think of shortest remaining time first. So among the various processes, just look at what all the timing the each process wants. So some halfway it has run and any some more time it has to run. Then look at which process needs shortest time. So allocate that. Or we can go for priority based. So whichever process, when more than one process wants to be executed, then look at the priority of each of the process. And the process which has got highest priority will be given first chance, then the second priority, then the third priority, and so. So the reason for calling this priority based, because when some low priority process is running and at that time high priority process comes up, then the low priority system is forced to stop, and then chance is given to the high priority system. If no high priority system is available, then the low priority system will be allowed to work, low priority process will be allowed to execute. But while low priority process is running, and that time if high priority process comes up, then the low priority process is stopped. So preemptiveness is required for that. Under non-preemptive, it's just first in first out queue is used for that, and whichever has requested first will be given the chance first. So just a queue is sufficient for that. Don't have to worry about timing and all that. Whoever asked service first will be given chance first. And shortage of first is another one. So when we are given with multiple processes, then just look at that which job requires shortest time, then first allocate the CPU to that one and all that. So with this, what happens is the average waiting time will reduce. For more details, we look at when we are actually working with in our next module, when we look at process management in detail. Then we have priority scheduling. So depending on the priority, so P1 has got priority 2, then P3 has got priority 1, and P2 has got priority 0. Therefore, the order in which it was run was highest priority 2. So P1 runs first, then next priority 1, that is with P3, then next priority 0, that is with P2. So P1, P3, P2, this way the processes are run.